Hopefully it'll all make sense and be pretty straightforward. I'm going to start with, before I do shifts, I'm just going to refresh our brains on shifts and how they work, and I think you guys will be okay with that. But if I start out with y equals x squared, just some basic parabola, I know my graph is going to look like that, and that's kind of like its parent function for this guy. And so we've done shifts based on that, and we would take like y equals and then go x minus 1 squared plus 2. And we've done things like this in the past. Hopefully we've done enough of these shifts that this is just like second nature for which way it goes, okay? First off, if we have this number on the inside and number on the outside, it moves the graph up, down, left, or right, depending on where it is, okay? If the number's on the outside of the higher power, which this higher power is the square, that 2 right there is going to move the graph either up or down. If it's on the outside, it stays as it is. So it's going to be a vertical shift up, going to go up 2. Okay, everybody okay with that? Now, if the number's on the inside, it's a left or right shift, and it's opposite, okay? So if it's on the inside, it's a negative 1. I'm actually going to shift to the right, positive 1. So I'm going to go to the right on this one, right 1. So my answer here, or my graph for the final answer here, I would go to the right 1, I would go up 2, and I would have my parabola, something like that. So it would be virtually the same parabola, just grab onto it and move it up or move it to the right or whatever you have. Okay? You guys all good with that? Now we're going to try to do that exact same thing, but with the sine and cosine. Okay? So let's say, and they write this in a couple different ways. You know how sometimes they write this like this? I don't know if you guys remember this, but sometimes they write this like this, 2 plus x minus 1 squared. Yeah. You know, sometimes they're jerks and write it like that. That's still a vertical up or down shift. That's not inside of that number right there, okay? So if it's not directly in front, it's not going to affect the steepness, but I think you guys are okay with that. So let's go ahead and look at one with the sine and cosine. Let's go ahead and start out with the sine one, super basic. Let's go ahead and say we have 3, and then sine of x, and then plus 2. Now, they'll write this in a couple different ways. They'll either write it like this, which is okay, or they'll write it like this, 2 plus 3 sine of x. Okay? Those mean the same thing. Okay? The reason they like to write it this way, which kind of sucks, but it's kind of good, this part right here, some people would think this x plus 2 is actually on the inside of the sine. And if it is on the inside, they would actually put parentheses on it like that, implying it's on the inside. Okay? So since there are no parentheses right there, since there's not any parentheses, then that plus 2 is on the outside. It's an up or down shift. Okay? And some people like to write it in the front because then they can see it as an up or down shift. It's going to be a positive 2 in the front. That's going to move this graph up 2. Okay? So I've actually got no number on the inside of the sine function. This 2 is not my amplitude. Okay? Very common mistake here. People see the 2 in the front, they're like, oh, that's my amplitude. Good. Your amplitude is 3 here still, right? Amplitude on this one would be 3, and then the period on this one would be 2 pi over 1, so 2 pi. Okay? So that would be, everything else is still the same. Okay, so amplitude is 3, and our period is going to be 2 pi still. So if I were to do the sine function, I would do a little mini sine function. Sine graph looks like that, and there's those 5 key points that you want to find. So what I'm going to do is I'm going to take my generic graph like this, and the first thing you want to do with these functions is apply a transformation to it. So this plus 2 is my transformation. I'm going to go right away. I'm going to go up 2, and I'm going to draw a new axis right here. Now, everything I do is going to be based off of this axis right here. I'm taking this sine graph, and I'm moving it up 2. So now it's going to be revolving around this new dotted line axis that I've drawn. So everything is relative to the dotted line axis that I'm working on. Okay? So my first point is the sine point is always at the origin, right? But everything got bumped up too. So it's going to be at the new origin, which is going to be this point right here. Okay? So you pretty much ignore this old line, this old axis. Just pretend it's not here for a little bit. Okay? We're going from the dotted line. First one is going to be our origin. Second one is going to be on our axis and at the end of our period. So we're going to go all the way to the end of the period, and we're going to put it right on the axis. Once again, on the new horizontal axis. Okay? The gap that I've traveled here, right? I've traveled a distance there. My period is going to be 2 pi. So I know I've traveled 2 pi like so. Okay, so now I can just cut it in half. So I'm going to cut it in half. Also, the middle point here is on the axis. So I put this right on the axis right there. Okay, that would be half of 2 pi, which is pi. I'm going to cut that in half. So that'll be pi over 2. And then this point right here is at the maximum. It's at the highest of the amplitude, right? So we're going to go up the amplitude. Amplitude is 3, okay? Now, the 3 is relative to this axis right here. So we're going to go up 3 from this axis, okay? So I'm going to extend this a little bit. I got to go 1, 2, 3 higher. So I'm actually going to be up at 5, looks like, okay? So the height of this is going to be all the way up at 5. Okay, now the amplitude is not 5. The amplitude is still 3. From our axis right here, it's going up 3 and down 3, okay? This point right here is in the middle. and it's in the middle of pi and 2 pi. So we'd add those together and divide by 2. Add those together, I get 3 pi. Divided by 2 is 3 pi over 2. So 3 pi over 2 is the guy in the middle. It's in the middle of this, and it's down in my amplitude, so I'm going to go down 3 from my new axis. Okay, so I'm going to go down 1, 2, 3. Puts me at this point right here. Okay, so we're actually down at -1 now. We got all 5 points graphed. Do the smooth curve between it. And there's our 1 cycle or 1 period. And you can just do that again. Pretend that wasn't bad. There we go. Okay? Feel pretty good? Not too bad, right? The up and downs are usually very, very, very simple. The up and downs are not bad. Okay? The biggest mistake people make is they put that on the inside of the sine and treat it as a left or right, and that's not going to be correct. Okay? All right, feeling semi-okay about that so far? Okay, let's do one with cosine, and then we'll make it a little harder and do the left or right shifts. The left or right shifts on this are significantly harder than the up or downs. Okay? So let's say I have y equals, and let's go ahead and do, we don't want to do that one. Let's go to -3 minus 2 cosine of pi x. So we'll go a little tougher on this one. First off, what's the amplitude on this one? 2. It's going up and down 2. Okay, the period on this one is going to be 2. That's nice. And then the shift, I like to think of the shift now. Okay, the shift, it goes up, down, left, right. Down 3. I got a -3 in the front, so it's actually going to go down 3 on this one. Okay, so we're going down 3 for our shift. Okay, we're also doing a cosine function. Cosine function, now I have this -2 in the front here, right? What's that going to do to the graph? Flip it, right? So as far as my cosine graph, normally it starts up, goes down, and finishes back up. That's going to get revolved around the new axis, right? So my actual graph is going to start down at the amplitude, come up, and then back down. So those are the 5 points that I want to find here, as opposed to these ones right here. Okay? So let's go ahead and graph this. First thing I would do is graph my new axis with my shift, with my up, down, left, and right shift. I'm going to go down 3. So I'm going to go down 3 first and draw a new horizontal axis, a new flat line. Okay? Everything is relative from that line now. Okay? You've got to pretend like the old axis isn't even there. Okay? So the first point is down at the amplitude. Amplitude is 2, and I want to go down from my new axis. So I'm going to go down 2 more, and I'm going to put a point right on that axis, right on the y-axis, and then down 2 from my new dotted line axis. Now I'm going to go to the end of the period. Okay, so the end of my period I'm going to say is right here. Just pretend. And that's also down at the amplitude, so that's going to finish down at the bottom. The gap I traveled there was 2. Okay, so I'm going to have this value right here was 2. That's my period. Okay, now I can just cut it in half. Half that would be 1. And that is, the in between on the cosine is up at the amplitude. So it's going to go up 2 from my new axis. So I'm going to go up 2, which will put me right here. And then now I split this in half. Go 1/2. That's on the new axis. Split this in half. That would be 1/2, 2/2. This would be 3/2. And then 4/2 for 2. Okay, and that's going to be right on the axis. That'll be right there. And I've got my cycle. Sound effects necessary. I feel pretty good. Okay? Up and down. Not too bad, I hope. Yes. The left or right is where it gets a little bit hairy. If you know what I mean.
Why does it get hairy?
I will show you.
Oh, gross.
Think.
Think your mom's feet.
Wow.
Brutal.
Let's do a sine one just to make it easy.
Sorry about that.
All right. So first you want to figure out the amplitude, the period, the shifts, the reflections, all of that fun stuff. So the amplitude on this one's still 2. The period on this one is 2 pi. There's nothing right in front of the x right here, so my period actually doesn't change. It's going to be a 2 pi for this particular one. And then I do have shift. This number's on the inside of the sine function, which means it's going to go left or right. It's opposite of what it is, so it's going to go to the right pi. Okay, so this one, the shift is going to go to the right a unit of pi.
Wait, why is it 2 pi?
It's 2 pi over 1 because the number in front of the x is the period of change.
Oh, number 4.
Yep.
Okay.
Because we did like a sine v of x. This affects the shift left or right. Okay. It gets kind of messy with the shift. Technically, I should actually worry about this pi divided by the number in front here to figure out what the shift is. But I'm going to avoid changing the period and a shift at the same time. So we're going to try to dodge those if we can.
Why can't you put the minus pi in front?
Why can't I put the minus pi? Well, first off, it's in parentheses, right?
What's the difference of the b?
If it's in parentheses, you have to, when you're plugging in numbers, you plug in numbers for x, you have to subtract pi first, and then you take the sign of that number, right? If this were on the outside, like let's say these parentheses weren't here like this, that would say plug in something for x, take the sign of x, multiply by 2, and then subtract pi.
So it only changes when you plug it in numbers.
It's changing when you're plugging in numbers, but if it changes when you plug it in numbers, it's going to change where the graph is, right? And so for our purpose, it's going to change for us too, unfortunately. So if there are parentheses there, if there are parentheses, that's a left or right shift, definitely. Okay? And no, I can't write it in the front because that would take it out of the parentheses. That's like me going like this. That's like me going x minus 2 squared. Yeah. And then saying, all right, well, I'm going to go negative 2 plus and then x squared. That's like me taking it out. Can't take it out of there. Okay? All right, cool. So that's going to be my shifts. Now let's go and see what this is going to look like. First thing I want to do the exact same thing I did last time is I want to draw a new axis, okay? So I want to apply that shift first. That's the first thing I want to take a look at. So my first application is my shift to the right, pi. So the first thing I would do is I would come out here, and it's kind of arbitrary how far you want to go. I'm going to call this pi out here, and I want to draw a new axis, and this is actually going to be a vertical axis now. I've basically taken the old axis right here and shifted it to the right pi. That's how you would do a left or right shift. Okay. Now what we want to do is everything is based off of this new axis. Okay. We're still doing the sine function, which is the up, down, up. Okay, that's this guy right here. And everything is based off of this new axis right here. So my first point for the sine function is going to be right at the axis, but I have a shift applied. I have to go to the right too. So my first point is going to be right here on that point, right on the new axis. Basically ignore that old line is even there. Okay, you're working from this dotted line now. Okay. Now we're going to go to the end of the period. So we're going to come out here. Once again, it's kind of arbitrary how far you come out. We're going to go to the end of the period, and that one is on the axis as well. So it's going to be on this axis right here. And here's the trick. Normally, what would the value be right here? 2 pi. It'd be how far you traveled, right? The problem is I went from this axis all the way over to here. That gap right there was 2 pi. So how far am I actually out right here? 3 pi. So I actually have to put a 3 pi on the end. Okay? That's the catch for this. That's the tough part for it. Okay? And then what makes this tough is we have to average all of them. So we have a lot of averages to do, right? A lot of averages. Okay? So this is how we do it. The catch there is I added the period to whatever my shift was. Okay? So I added the period to the shift. So that entire gap was 2 pi. Okay? Now I can do my splits. I can do my averages, right? I can average these two. I can split that in the middle. Put that point on the axis because it's the sine function. And now I got to figure out what's in the middle of pi and 3 pi. So I have to add them together and then divide by 2, right? So if you add those together, you get 4 pi divided by 2 is 2 pi. So I should get a 2 pi for that guy in the middle. Everybody okay with that? Okay. Now we're going to average this one, split that in half. And that's up at the amplitude. The amplitude on this one is 2. So I need to go up 2. And my amplitude is up 2. That'd be this point right there. I need to split this one in half and go down 2. So I'm going to go down to negative 2. Put that point down here. And now I got to figure out what those x values are. Okay. Remember, that's half of what I'm going to be looking for when I'm grading these. Okay. So I have to find the average between pi and 2 pi. So I add them together and divide by 2. So if I add those together, I get 3 pi. Divided by 2 is 3 pi over 2. So 3 pi over 2. I picked an easy one to start with, just FYI. Okay. 2 pi and 3 pi, we're going to average those. So we're going to add those together and divide by 2. So if I add those together, I get 5 pi. Divide that by 2 is 5 pi over 2. So I get 5 pi over 2. Okay? Got all my points. Nice smooth curve. And do one more just for fun. And we're good. Everybody okay with that? That seemed reasonable, at least, I hope. Okay, so it's actually kind of nice. I know at the beginning it was kind of ugly. It's like, ooh, we have a shift of a pi. That's gross. But it's actually kind of nice because all these numbers down here are in terms of pi anyways, and so it makes the averaging a lot easier. I don't have to do a pi denominator or anything like that. It's kind of gross. So. All right, cool. Let's do one with cosine, and then we'll do one super hard one, and then call it good. Okay?
Hard.
Ridiculously hard.
Like if you don't get it.
Like as hard as it possibly can.
It's college.
Like college kids can't do this problem. Yeah,
Like can you
barely. I just struggle through this. Which problem is it going to do?
I've never heard of that. You barely make it through a math problem. I just need it. You can do it or not. You can
close.
just barely do it.
I wanted to do
Cosine.
cosine. Yeah, that's what I wanted to do. I wanted to do a negative 2 cosine of x plus pi over 2. So amplitude and period, I still always want to look for those. Feels like my amplitude I've been picking on too today a little bit. Apologize to the poor guy. Poor guy, he didn't do anything to me.
I apologize too.
You said too. What color is it? All right, so
So what that stands for.
that's what that
2
stands
pi.
for. So 2 pi is the period, right? We have a little bit of stuff going on here. We actually have a negative right here, which this is going to flip it over. So it's going to flip the cosine graph over, which means it's going to start down and then back up and then back down, right? So those are the 5 points that I want to find. And then now I've got a shift. This one's a little tougher. I got a plus pi over 2. So which way is this graph going to go? To the left, okay? I'm going to have a shift. It's going to go to the left, pi over 2. Thanks, Beyonce. I looked that up just so I could be cool. Yeah, thank you, Google. I like it.
iTunes previews.
Something like that. Okay, so let's go ahead and graph this. Now, once again, I would draw my new axis first, so I'm going to go to the left, pi over 2 first. So I'm going to go to the left here, and once again, it's arbitrary. So it might not be perfect, it might not be great, but it'll be close enough for me, okay? So we got pi over 2. The left shifts are always kind of weird because we're going to be revolving around 0, so your picture might not be perfect to scale, okay? Which is going to be kind of weird for some people, but it'll be right. So we're going to go pi over 2. Now we went left, so technically this is actually a negative pi over 2 as far as my values go, okay? That negative is important for when I add the period to it in a second, okay? So now that first point is going to be down at my amplitude, right? And the amplitude is 2. So that means I forgot, I'm just going to draw my new axis, sorry. Okay, so now I want to go down 2, so I'm going to go down 2, and my first point is going to be right there for my cosine graph. Now I'm going to go to the end of the period, so I'm going to come out here somewhere, and once again, it's kind of arbitrary how far you go. If you want, you can find your values first. You can find your 5 values first before you graph it. That might help some people with where it goes on the graph. But anyways, the end of the period, the distance I travel here is the period, which is 2 pi. So I have to add 2 pi to this guy because the gap from here to here is 2 pi. So I need to add 2 pi to negative pi over 2. So I have to go negative pi over 2, and I have to add 2 pi to that guy. So I have to do a little bit of work here to find my end value. Okay, so on this one, I need a common denominator. So I need a 2 on the bottom here and another 2 up here, which gives me 4 pi minus 1, right? So this is going to be a 3 pi over 2. Okay, so 3 pi over 2 should be my right endpoint for this guy. It should be 3 pi over 2. Okay, negative pi over 2 plus the 2 pi gets me to 3 pi over 2. So that's how far I've traveled. Okay? So now once you have that, it's all averages from there. Okay? That's usually the hard part is getting that first one. Once you get the first one, you're kind of off to the races. Okay? So I'm going to take this out of there. That point is going to be down at the amplitude, so it's going to finish down at 2 as well. Okay, I'm going to average those. So I'm going to split that gap in half. Okay, so I split that in half. The cosine in the middle of it goes way up at the amplitude, so I'm going to go up 2. So that's going to put me right up here. Okay, and then I'm going to average these two. So I'm going to add them together and then divide them by 2. Okay, so it's a little bit weird, but I got to add those together and divide by 2. Yeah. I'll end up counting it probably because I think I'm gonna get lucky and it's gonna land on 0, but we're gonna find out. So if I average these, I'm gonna add them together and then divide by 2, right? So I'm gonna slide this up here. So if I go negative pi over 2 plus 3 pi over 2 and then divide that by 2, that's the average of those two, right? So I need to go. Let's see. This would be 2 pi over 2, right? Okay. That's up as it goes.
Oh, okay.
I guess I can do this. Right there. So add this together, I get 2 pi over 2, right? Divided by 2, which is 2 pi over 4, which would be pi over 2. Okay, so pi over 2 right there is the average between these two values right there. I add them together and then divide it by 2. Okay, so I'm going to put a pi over 2 right here. So this is going to be pi over 2. Now I'm going to average negative pi over 2 and pi over 2, which is a tough one. 0. Yes, 0. It's in between it, right? Okay. So 0. So actually I got lucky, and that point's going to be right on the origin. Not always going to work out that nicely. I just picked a good one. Okay, and now I got to average these two. I guess we could just add pi over 2 to that. That'd be the counting principle. Negative pi over 2, 0, 1 pi over 2, 2 pi over 2, 3 pi over 2. Anyways, so that point would be right here on the axis as well. I'm going to add these together and divide by 2. So if I go pi over 2 plus 3 pi over 2, and then divide all that by 2, that'll give me the average between those two. And so that's 4 pi over 2, so that's 4 pi over 8. And 4 pi over 8, no. 4 pi over 4. I'm sorry, I'm retarded. 4 pi over 4, which should just be pi. So that was going to simplify to pi. So this value right here is just going to be a pi, which would work with our little counting mechanism. It would be negative pi over 2, 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2. Works out pretty good. Okay. So that's one with the cosine. For the left shift, the left shifts are always kind of the weird ones to do. Just FYI. Okay. All right. Are we feeling semi okay? Semi?
Not really.
I'm working. My brain's working. I'm not good at though.
TMI.
Oh, too much information. Last one, and then we're done. Let's make this one the hardest one possible. Ooh, let's do this one.
I was eating that.
Oh, yeah.
Someone talked to
Throw away some cocoa ball.
No, okay. So, story. Oh.
This one's got everything but the kitchen sink.
You can't do that for yourself or it's lame.
Why not?
Lift that up.
Because that's what makes it funny. Right?
TMI.
Because it's so lame. Don't overuse it.
He is. He overuses everything.
It's like overusing.
It's like I overuse
I hate when people overuse.
Yeah.
It just drives me nuts.
Overuse your ball.
How do they do that?
You're recording right now, just FYI.
TMI. What'd you say? I can't say it again.
All right, let's do this. So the amplitude, I didn't pick 2. Not 2.
I know.
It's 3.
There's a mic's over there, then
Mike hears all,
it was you pretty good though.
which means it hears them even better.
Distance ratio thing.
You're me too, right?
Oh man. Let's see. So period is 2 pi. We got some shifts here. What are my shifts for this one?
Up to.
Up 2.
Left.
All right, 3. Left. Yep. Pi over 3. And it's flipped. Okay, because there's a negative in front of the amplitude. So this one's flipped. So my sine function is actually going to go like this now.
Basically just trying to kill us.
Trying to kill you. Trying to do all of it together. TMI.
No, TMM.
Oh.
Too much
Good with
math.
that one too.
Ooh.
TM squared.
TM squared. There it is.
Better. Okay, here we go. So let's go ahead and figure this guy out if we can. So first thing I would do is I would apply the shifts and do my new axis. Okay, so I'm going to go up 2. New axis like so. I'm going to go left pi over 3. So this would be a negative pi over 3, which is kind of weird. Negative pi over 3, and that's going to be my new axis here. Okay? Pretend that was a straight line. Just try that again. Yeah, I recovered well. I will. So my sine function, okay, sine function for this one starts at the origin. Now it's the new origin, okay? New origin would actually be this point right here. It's not even on any of the axes on the original. So that's the way it goes. That's my first point. My end point, I'm going to come all the way out here somewhere. And I'll show you how your scale might be a smidge off, okay? It might be. We're just going to ignore this line right here for now, okay? So my period, I'm going to travel a distance of 2 pi on this one. And the period is going to be on my new axis, which is going to be up at 2 right here, okay? So I need to add 2 pi to this guy. So I'm going to go negative pi over 3, and then add the period, which the period for us is going to be at 2 pi. So we're going to add the period of 2 pi. Need a common denominator here of 3, so I need a 3 and a 3, which would be 6 pi. 6 pi minus 1 would be negative, no, it would be 5 pi over 3. So 5 pi over 3 would be the end of my period. That would be the end of the cycle. So 5 pi over 3. Okay? The middle point is on the axis, so I'm going to go middle point here on the axis, right there. That's pretty good. I have to average these two. So if I average these together, I want to add them together and then divide by 2. So if I add these together, I get 4 pi over 3. Divided by 2 is 4 pi over 6, right? Which reduces to 2 pi over 3. I kind of did a lot out loud there. Feel free to write it down. Negative pi over 3 plus 5 pi over 3 is 4 pi over 3. Cut that in half, so I double the denominator. It's 4 pi over 6. And then 4/6 reduces to 2/3. So 2 pi over 3. Okay? You could also do this. Ignore the denominators. What's the average of 5 and negative 1? 2, right? Okay, so it'd be 2 pi. Now we're going to average those again. Okay, so we're going to average these. Now 0 is not in the middle of negative pi over 3 and pi over 3 anymore. So I'm going to try to just kind of eyeball it and average those like that. Might not be perfect to scale, but we're going to give it a try. Okay, so I'm going to take the average of those. This point is going to be down at the amplitude because remember the sine got reflected. So we're going to go down 3 now. Okay, so for my new axis right here, I'm going to go down 3. So 1, 2, 3 is going to be right here. And then this average right here is going to be up 3, so I'm going to go up 3 more from my new axis. So I'm going to go up, it's actually going to be a grand total of 5 there. So I'll be up there, like that. Okay, so I've got my sine curve. Okay, I'm going to find both of these values now. So I need to average these two, add them together, and divide by 2. Okay, so if I add these together, I get 1 pi over 3. So if I divide that by 2, it's pi over 6. So this right here would be pi over 6. Ooh, my counting mechanism kind of failed me a little bit now, right? This would be kind of a weird thing to count, right? So unfortunately, we probably should just stick with our averages on this one. So we need to add these together and divide by 2. Well, then already got a common denominator. That's kind of nice. So add them together, get 7 pi over 3. So double the denominator, 7 pi over 6. 7 pi over 6. If you try really hard, there still is a counting mechanism in there, okay? But it's not with a common denominator, so it's kind of tough to see. But it'd have to be a denominator of 6. This would be 4 pi over 6. So it's actually going up by 1 pi over 6. This would be 4 pi over 6, 7 pi over 6. How much are we adding there? 3. 3 pi over 6. We're actually adding pi over 2 every time there. So 3 pi over 6. If I had 3 pi over 6, that'd give me 10 pi over 6, which reduces to 5 pi over 3. So our counting mechanism would still be there, but it's kind of tough to see when it's gross like that. So, anyways, we're getting the general idea, I hope. Okay, we're on page 496, and we're 41 to 50.